Hello researchers, today we're gonna talk about MzDOCK, which is a new software which we have built for the simplification of molecular docking. The team which we have worked for the development of MzDOCK, as you could see in the screen, we have a really nice team and we have worked towards this with a vision that the molecular docking becomes easy to use as well as free and fast, as the more focus should be on the data interpretation rather than the technical aspects. So as Dr. Bijo Matthew has already explained in a YouTube video about how the basic pipeline is in the MzDOCK, as you could see in the screen, it's the GUI of the MzDOCK and it's easy. As you could see, it's well labeled and it actually guides the user towards all the process of molecular docking. So this can be beneficial for beginners as well as the professionals. So first what we do is we will select the ligand and prepare, select the protein, select the co-crystallized ligand which will define our binding site. Then we will run the docking, and then what we're gonna do is analyze the interactions. So we're gonna do it step by step. So what's new? As in the previous video we have explained the basic pipeline. What's new in this video is that we have introduced new features into this. Actually, we have integrated Pymol open source into this, so that the user doesn't have to explicitly download Pymol actually. So the Pymol is available within the MzDOCK itself, so this actually simplifies the process. And there is integration of a molecular sketching tool as well, so we can see in detail actually about this. Yes, there is a new button which we have introduced where when the user clicks it, it opens a Pymol. Then there is a molecular drawing tool actually, where the user can actually draw their molecule, which is very useful for chemists. So we have made this with the JSME editor actually, and it actually creates a smiles where you could copy and paste it into the MzDOCK. So we have opened the MzDOCK. Actually, the first thing you have to do is click on the new button which starts a new session actually. Then what I want to say is there are a lot of doubts regarding the multiple ligand docking for some users, so we're gonna explain about it. So what you're gonna do is select the ligand button and then click on the load button, and there's how to do multiple ligand docking is first you have to create a folder. So we have already created a folder and we actually put the files that we have to dock into this particular folder. So I have kept 2 SDF files in it, and then we're gonna choose the select SDF button. Then we're gonna go to the folder and we're gonna drag all of them. So now you could see that 2 of them I have selected. Then just click on the open button and then just prepare it. As you could see, 2 ligands are actually getting prepared right now, and a message box actually appears which indicates number of ligands prepared. So that's a good job. So the next thing is the features that we have added into the MzDOCK. So the MzDOCK actually now has Pymol integrated into it. As you could see the button over here, Pymol, when you click on it, the Pymol actually appears, which is open source, and this is a good little feature which we have added, and this can help people. So then the next thing is you can actually type in the PDB ID over here. So I'm gonna choose 2V5Z, which is the protein that we are gonna use for docking, and it actually extracts the protein. And if you want to extract a particular chain, just type its letter. So then when you press on confirm, the chain is actually extracted, and when you press on the zoom, you could actually see the protein. Okay, we have extracted it. And when you click on the prepare, there are a lot of options which we can change: charges, which is important. You could browse through the different options like home and as well as guest teacher, and there is an option for cleanup where you can keep the water or delete the water. And the ligand science section is where the interesting part is, where we have provided an option to retain cofactors and ions. So when you choose this particular option manual, as you could see, there is a widget which appears, and especially in this scenario we have to retain FAD cofactor, which is pretty significant, especially in this scenario, its influence on the interactions. So in the terminal actually you could see what ligands, cofactors and ions are present in the protein. So there is a FAD cofactor as well as a SAG, which indicates the safinamide. So what you're gonna do is we're gonna type this 3-letter code over here, and we're gonna add it into the list, confirm it, and just press on the confirm button. This actually retains the FAD, and you could confirm it by looking at the terminal, deleting non-standard residues, SAG. Only SAG from the chain A has only been deleted. So this means that the FAD has been retained. So the next thing you're gonna do is select your co-crystallized ligand. MzDOCK primarily focus on guiding the user to choose their co-crystallized ligand, and here in this case SAG is, as you could see, it's indicated by the 3-letter code on the left corner. This SAG is the code representing the safinamide. This you could confirm it by looking in the notepad, by opening your PDB file, or you could just confirm it in the website, the PDB website. So then you could just press when the safinamide co-crystallized ligand is present in this window, just press on the confirm. So this actually confirms this particular header item. So then I'm gonna click on the prepare button. Then every process has been completed: selection of the ligand, selection of the protein, configuration of the binding site. Now what's left is running the docking. So just run the docking. As you could see, it's running. So we're gonna save the output files generated into this folder. So yes, there is safinamide log as well as output pdbqt file. So the next thing we're gonna do is compare the co-crystallized ligand pose as well as our docked pose. So we have did redocking actually with the safinamide. The safinamide is a co-crystallized ligand as well. So to compare, we have to get the co-crystallized ligand. So you can actually get this with the get C ligand button, and you can save it in your folder. So then just click on the Pymol button, which produces the window, and then just drag the co-crystallized ligand. This is the pose. This is the pose which we have actually got from the protein. Now we're gonna compare it with the pdbqt which we have generated. So as you could see, the RMST is pretty low in this case, and it's there is certain changes, but it's actually close. So yes, so this is a way to validate your docking scoring function. So this is a kind of a necessary step when you have to do, so that you can know that your docking application is really optimized for your particular target. So the next thing that we didn't mention over here is the molecular editing tool. So actually, when you go through to the ligand preparation widget, there is a draw mold button actually over here. Just click on the draw mold button, and it actually leads you to this HTML screen. So this here you can actually draw your particular ligand, and what you could do is you can copy the smiles which we have which gets automatically generated over here, and just give it to this smiles line edit, and just click on the OK button, and as you could see, the number of ligands are prepared. This is the secondary option that we had, and I hope this actually helps people a lot. And you could also analyze the interactions as well, which Professor Bijo Matthew has actually explained this before. The purpose of this video was to explain the new features as well as discussing doubts that the users had. For citations, actually the MzDOCK got into the Journal of Computational Chemistry, and for citation actually you could refer this. So the MzDOCK actually can be downloaded from the source forge. Just type in the Google MzDOCK and it actually appears, and this has been downloaded all over the country right now, and it's fastly growing. And I hope this has been an interesting video, and in case of any doubts, just contact any of the others. We will actually rectify that, and I hope we are helping you. Thank you.